All right, welcome to the video on 4.6, variation of parameters. Okay, so this is another way to solve non-homogeneous differential equations. Okay, we're going to look at it first, of course, with non-homogeneous, constant coefficient, second order linear. Okay, so we have AY double prime plus BY. Oh, you know what? I like the fonts a little bit bigger, thicker. AY double prime plus BY prime plus CY equals F of T. Okay, so this has, again, just to sort of keep in mind, it's non-homogeneous. I mean, provided that F of T is not equal to 0, right? Okay, it's linear in that your derivatives are all showing up linear. There's no like y prime squared or y cubed term or whatever. Okay, constant coefficient. Most of what we do here is in the constant coefficient world, where that means these a, b, and c's, those are just constants. Those are not functions themselves. That would make the problem a lot harder. Okay, so we're going to look at this sort of problem. We already did this in 4.5 and 4.4 with undetermined coefficients. Now we're going to look at a more general way to solve this thing. Okay, so let's suppose that y1 of t and y2 of t both, getting into the habit of writing cursive, both solve the homogeneous problem. Okay, so if they both solve the homogeneous problem, that is AYI double prime plus BYI prime plus CYI equals 0. Okay, and we're going to assume a special form for the particular solution. Okay. Let me get rid of, I don't like using particular twice. So assume a form for the particular solution. Y sub p of t, and we're going to assume that it's of the form v sub 1 of t, y1 of t, plus v sub 2 of t, y2 of t. Okay, and we're going to see what that gets us. Okay, so the first thing we're going to do, we're going to plug it into the original equation. Okay, so that means we need to find yp prime and yp double prime. Okay, so yp prime of t is going to be, or is, v1 prime y1 plus v1 y1 prime plus v2 prime y2 plus v2 y2 prime. Okay, now here we're going to make our first assumption. Okay, so we're going to make an assumption. Well, actually, it's our second assumption because we assumed this Okay, but we're going to make another assumption about V1 and Y, V1 and V2. Okay, we're going to assume that V1 prime Y1 plus V2 prime Y2 equals 0. And the reason that we're going to do that is because we want to avoid having derivatives of V1 and V2 in the next step, in the next derivative. Okay, so if we assume that, then I'm going to simplify yp prime as a function of t, of course, is equal to v1 y1 prime plus v2 y2 prime. Okay, now let's take the second derivative of yp. So yp double prime is going to be v1 prime y1 prime plus v1 y1 double prime plus v2 prime y2 prime plus v2 y2 double prime. Okay. Okay, so these are our, here is our yp prime that we're going to use. Oh, let's use the yellow highlighter. And here is the yp double prime that we're going to use. Now, the next thing we're going to do, we're going to plug these back in to the original equation. Okay, so let's plug them into the original equation. That is ayp prime, double prime plus byp prime plus cyp equals f of t. Okay. All right, so that's going to be a times this baby right here. I don't know if I say this enough, but I'm telling you, having a screen to work like this to do math, it's a life changer. Okay, so Apple should put me on their payroll because I hated Apple products, but now I don't know what I would do without this thing. I mean, I know what I would do, but I don't think I would want to go back to it. Okay, so far so good, right? But now remember, ay1 double prime plus by2 prime plus cy, I'm sorry, ay1 double prime plus by1 prime plus cy1 should equal 0, right? So let's take a look at these terms here. I'm going to look at that. So this term with this term and this term, those are going to be give me 0, right? Because it's got the v1 on all of them, and they have the homogeneous equation there. Okay, I'm going to go with another color highlighter. The v2s, I'm sorry, the y2 double prime, ay2 double prime plus by2 prime plus cy2 is also going to equal 0. So this term with this term with this term is going to give me 0. Oh, wow, look at that. So what are we left with? All we're left with okay, after considering that let's write it here in red, v1 times ay1 double prime plus by1 prime plus cy1 equals 0, and v2 times ay2 double prime plus by2 prime plus cy2, those both equal 0. Okay, so one was marked out in yellow, one in green. Okay, if you're colorblind, that's okay, I am too, but I can see the difference between these two, which is saying something. Yellow-green is always tough. Okay, but what am I left with? I'm left with a v1 prime y1 prime plus a v2 prime y2 prime equals f of t. So this is an equation we have. We had another equation up here. Where was it? Right here. Look at that. We have a system for v1 prime and v2 prime. Okay, so let me give these, let's give this the name equation 1, this the name of equation 2, and we have the following system. ay1, oh, let me write it this way instead. Sorry. y1, y2, ay1 prime, ay2 prime. Let's actually write that without the a here. Reason is you'll see in a shortly. So here we have v1 prime, v2 prime equals 0 and 1 over a f of t. Okay, so let's just make sure that works. v1 prime times y1 plus v2 prime times y2, that's that first equation. The second equation, y1 prime times v1 prime plus y2 prime times v2 prime should equal 1 over a f of t. Okay, so I'm going to go ahead, let's stop the video here. We'll look at how to solve this problem in the next video.